Hello friends, we are seeing the electronics paper first, basics of applied electronics. In this paper, we had seen the fundamentals of electronics, and in that unit we saw different components, electronic components, resistors, capacitors, inductors, their specifications. Then we saw the series and parallel combination of resistor, capacitor, inductor. Also we had seen the batteries, different types of batteries, relays, voltage and current sources, etc. So today we are starting new unit 2, that is network theorems. In this network theorems, we have to see Kirchoff's laws, then Thevenin's theorem, Norton's theorem, superposition theorem, maximum power transfer theorem, and their DC and AC analysis. So first we will see what is network. Network is nothing but the complex circuit, or it is a combination of components connected in any way. For analysis of network, generally we need different rules, so they are called as network theorem. The network theorems are shorter methods for solving the circuits, and by using the network theorem, one can convert the complex circuit into the simple equivalent circuit. So before going to start the network theorem, we will get introduction of one scientist here, Léon Charles Thevenin. He is a French scientist and a French telegraph engineer. He extended the Ohm's law to the analysis of complex circuit and developed his famous theorem, that is Thevenin's theorem, which is useful to calculate the currents in more complex electrical circuits and to reduce the complex circuits into the simpler circuits. So it is also called as the Thevenin's equivalent circuits. Likewise, we are going to see the Norton's theorem and maximum power transfer theorem and superposition theorem. The network analysis means to find out the voltage across and current through each element in the network, and for this purpose we apply the Ohm's law, Kirchoff's laws and certain mathematical calculations to the circuits. So first we will see Kirchoff's circuit laws. In 1845, a German physicist, Gustav Kirchoff, developed a pair or set of rules or laws which deal with the conservation of current and energy within the electrical circuit. These two rules are commonly known as Kirchoff's circuit laws. In that, the law deals with the current flowing around a closed circuit is known as the Kirchoff's current law, while the law deals with the voltage sources present in a closed circuit is known as the Kirchoff's voltage law. So we will see first Kirchoff's current law. The Kirchoff's current law, in short we call it as KCL. It states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node. I will repeat the statement again. The total current or charge entering a junction or node, एखाद्या जंक्शन किंवा नोड कडे येणारे करंट एंटरिंग entering current is exactly equal to the charge leaving the node. ते लिव्हिंग नोडच्या इक्वल असतात, लिव्हिंग द सेम नोड. In other words, the algebraic sum of all the currents entering and leaving a node must be equal to 0. म्हणजेच आपण असं म्हणू शकतो की if we consider a node and at that node the algebraic sum, algebraic means why we are saying here algebraic, because the current entering are positive and current going are considered as negative. So algebraic means we have to take their algebraic sum at the same node must be equal to 0. Mathematically we can write it as I entering plus I leaving is equal to 0, and Kirchoff's called it as the conservation of charge. This Kirchoff's current law is known as the conservation of charge. So we will discuss further, or we will diagrammatically reveal about this Kirchoff's current law. We can see here, diagram is shown here, the current entering a node and current leaving a node are shown here. This is the node where currents are entering and leaving the node. In that, the arrow pointed towards the node are known as current entering, that is current in, and arrow pointed outward from the node, they are called as current leaving the node, that is current out, we can see here. So if we apply statement here, what is the statement? The total current entering the node is equal to the current leaving the node. So mathematically we can write here, current entering are here I1, I2, I3. Three currents entering the node, that is I1, I2, I3. They are all positive in value, and two currents leaving the node, that is I4 and I5, they are negative in value. So we can write the equation as I1 plus I2 plus I3 plus into bracket minus I4 plus minus I5 is equal to 0, and so we can rewrite the equation as I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. This Kirchoff's current law is used for analyzing the parallel circuits. Further, we have to see Kirchoff's voltage law. It states that in any closed loop network, the total voltage rises around the loop is equal to the sum of the all voltage drops within the same loop. In other words, the algebraic sum of all voltages within the loop must be equal to 0. Here in KVL, in any closed loop, कोणत्याही closed loop मध्ये त्या ठिकाणी जे व्होल्टेज सोर्सेस असणार आहेत, व्होल्टेज राइजेस म्हणजे अप्लाइड व्होल्टेजेस and voltage drops means we can say the voltage drop across any component like resistor. So voltage rises is equal to voltage drops, or total voltage around or algebraic sum of all voltages within a loop must be equal to 0, and this law is called as a conservation of energy. This diagrammatically can be explained here. One loop is shown here, A, B, C, D, it is a closed loop, A, B, C, D, A, it is a closed loop, and here the sum of all the voltage rises and drops around the loop is equal to 0. Actually here resistors shown R, so the voltages will be drops, and we can write here VAB plus V means voltage across this point, VAB across this branch, and this branch. So, we can write here VAB plus VBC plus VCD plus VDA is equal to 0, and must remember the Kirchoff's voltage law used for analyzing the series circuit. Okay. So, we will stop here.